Right now, something extraordinary is unfolding near the heart of our solar system. The interstellar visitor known as 3I, Atlas, only the third confirmed object ever to enter from beyond our star's domain, is plunging toward the Sun at breathtaking speed. It's already moving faster than any spacecraft humanity has ever built, nearly 68 kilometers per second, cutting through space with the precision of a blade. Its path carries it inside the orbit of Mars, tilted at an angle so steep it's almost head-on against the planet's natural flow. This is no ordinary comet. This is a true outsider, a fragment of another star system hurtling through ours on a one-way journey that will never return. At this moment, 3I, Atlas is on approach to its closest pass to the Sun, its perihelion, scheduled for October 29. But there's a cruel twist. Just as this happens, Earth enters solar conjunction, the period when the Sun's glare blocks our line of sight. Every telescope, from the ground to orbit, will go blind. The world's astronomers can only watch as their instruments are silenced, knowing that the most mysterious object in decades is slipping into the Sun's electromagnetic storm, invisible and unreachable. When 3I, Atlas first appeared in July, it was traveling at 58 kilometers per second. Since then, it's only accelerated, feeding on the pull of the Sun's gravity. Imagine something possibly 50 kilometers across, as wide as a city, slicing through the solar system fast enough to cross the distance from Earth to the Moon in a little over an hour. Its orbit is hyperbolic, its eccentricity greater than 1, meaning it's not bound to our Sun. Once it leaves, it's gone forever. Yet in this brief encounter, it has already defied expectations at every turn. As it approached the inner planets, its surface chemistry began changing dramatically. Telescopes picked up an unexpected shift in color, from red to a brilliant green glow, a sign of carbon-rich molecules reacting to sunlight. This isn't the normal behavior of a comet. Most are driven by water vapor, but Atlas seems powered by carbon dioxide and exotic compounds rarely seen in our solar system. Spectroscopic readings even revealed an unusually high nickel content, something scientists have never observed in such abundance before. That discovery led to bold new theories. Perhaps this object came from the remains of a shattered planet orbiting a distant star, or even from the aftermath of a supernova explosion. Its light behaves strangely, too. The coma, the glowing gas surrounding its core, brightens on the Sun-facing side instead of trailing behind it. Some experts think it's coated in metallic dust that reflects light like a mirror. Others suspect electrical activity, as if solar-wind interactions are charging the material around it. This could explain the object's persistent brightness even as it nears the Sun, when most comets begin to fade or fragment. If that's true, 3I, Atlas isn't just being illuminated by sunlight, it's responding to it. But now, that story has gone dark. Since October 18, the object's apparent distance from the Sun has dropped below what even the most advanced observatories can track. It's too faint for solar imaging satellites like SOHO or Stereo, too close for ground-based telescopes, and too risky for infrared sensors. Engineers can't override their safety systems without burning the detectors. For the next several weeks, there will be nothing but silence. The world will have no idea what's happening out there, whether the comet holds together, fractures apart, or undergoes some kind of transformation as it faces the Sun's electromagnetic fury. If 3I, Atlas interacts electrically with the solar wind, scientists predict they might see a burst of radiation, a flash, or even a shift in its trajectory when it re-emerges. But those are only guesses. Everything now depends on what happens during this hidden moment, a moment no one can witness. It's an agonizing wait for the teams who have spent months tracking it, logging over 100 coordinated observations, and building models to predict its behavior. The object that has confounded them for months is now beyond reach, racing through the light of the Sun itself. When it returns to view in late November, astronomers hope to catch the first glimpse of its post-perihelion state. Will it still be intact? Will its coma or chemical signature have changed? Or will it have faded into the background, leaving only a trail of mystery behind? Its next milestone comes on December 19, when it makes its closest approach to Earth, still distant, at around 1.8 astronomical units, but close enough for telescopes to attempt recovery. By then, the data blackout will have stretched for weeks, and speculation will be at its peak. If Atlas survives, it could offer answers to some of the biggest questions in planetary science: how solid interstellar bodies form, what materials exist beyond our star, and whether something like this could ever seed life between systems. But if it doesn't, we may be left only with fragments, and a fleeting story of something that came from the stars, burned past the sun, and vanished forever. For now,